So, welcome to Meteors.
What? I thought you just talking to me about when you said fuel wrap.
I know, I dislike you.
So the first thing that we got to realize about meteors is, number one, they look cool. So stare for a moment. In the past, meteors were not seen as awful like comets, so at least they got that going for them. In the past, this will move eventually. You don't have to write down the next slide. It's going to be on the handout that I give you. So until the early 1800s, they were thought to be something that was produced in the atmosphere. People didn't think that they were actually tiny little pieces of dust and rock that were impacting our atmosphere from outer space. They thought it was just something no different than lightning or hail. But eventually, in 1833, they figured out that they were actually things that were coming from beyond our atmosphere. So from this slide, I'm going to hand out your handout here. And when I give this to you, what I'd like you to put an arrow next to is the very first bullet point. That's the only thing you need to emphasize from this first slide. You don't need to do anything about the slide that says in the past, but this one that's up, first bullet point, put a little arrow next to it. So the confusing thing about this word is that there's two others just like it. There's meteoroid, there is meteor, and there is meteorite. And they all mean different things. So make sure you know that meteoroid is basically the piece of rock or dust or whatever that's going to turn into a shooting star. It's that object before we actually see it screeching through our atmosphere. So I say it's a shooting star before they shoot. And that's what a meteoroid is. And you'll hear the other ones later, but I'll just kind of say them right now too, so you kind of get it in your mind to start. A meteor is a shooting star. It's when you actually see that streak of light across the sky. A meteorite is when that actual piece of rock has made it all the way to the surface of the earth, and you can pick it up and look at it. So meteorite would be after everything happens. Meteoroid is before everything happens. So there's some meteoroids heading towards Earth. Meteor, of course, as I just mentioned, is actually the thing when it's streaking through the sky. From this slide, put a little arrow next to the first bullet point and the third bullet point, please. Those are important things to know. First and third. Now, this does not really apply to where we're located here, so close to Milwaukee. This is something you would see if you're in a more rural area with less light pollution. Yes?
Have you been to North County?
Yeah.
Have you been to North Fork?
Probably. I don't remember specifically, though.
It's the one, it's like the designated state park for like studying.
Oh, nice. Yeah, if you can find a place like that, and you look up at the sky, I'll tell you what, you don't see the same sky that you're going to see above your head tonight. There are so many stars up there that you wouldn't even believe it. I encourage you to check that out sometime. And it doesn't even have to be way up in Door County. Just head west, and eventually you get away from most things, as long as you're not heading towards Madison. Yeah, that's a rather big meteor. And it would be a meteor because it's actually streaking through the sky at this point. In case you're wondering about these transition, it's set to random. Thought that'd be fun. Now, a picture like this is taken on a time-lapse camera where they just leave the shutter open and it records for a while, and that would just be that streak from the meteor going across the sky.
How would they know?
Yeah, they just leave it open for a while. So for this slide, go ahead and write down the title. Go ahead and write down the first bullet point and the first dash. Yeah, that'll be enough for that one. The title up here, the bullet point there, first dash, and did I say last dash? I don't remember. No, I don't think so. Yeah, just title, bullet point, first dash mark. That should be plenty. So yeah, what makes fireballs and what makes meteors is when something enters the Earth's atmosphere, it's being pulled. It's being pulled by Earth's gravity. So it's moving faster and faster and faster and faster. And even if there's nothing for it to hit, it's still going to feel tons and tons of friction. It's like if you're on the highway and you stick your arm outside the window, you can really tell there's a lot of air there. You feel that air friction. Now imagine going hundreds upon hundreds of miles an hour. That's what happens with meteors. That's what happens with fireballs. They're burning up because that friction is so strong that it heats it up to the point where it just kind of disintegrates into flames. And a fireball is just basically a meteor on steroids. It's a larger object than what would produce a meteor. So what if a meteoroid is a lot more than just a few inches across? Write that down, write the first bullet point. Also, write down this here. So just do the whole slide for this one. Bless you. Yeah, sure. Is the Christmas tree in the way? Okay. Just... As you would probably expect, meteors of all these are the most common. Fireballs are less common. Bolides are even less common. You like how I made these two letters white? See how I look out for you guys? easier to read. And this is a picture in the background of a bolide. It's something that's actually going to explode. It's not just going to streak across the sky and end like a fireball or like a meteor. It actually will have a bit of an explosion at the very end. And just typically when you see these or when you see fireballs, they're usually moving through the sky slower than meteors do. Meteors go through and it looks like they just zip for a second or two and they're gone. If you're looking at a good fireball or a bolide, it's going to look like it's taking a lot longer to go through the sky. And that's because it's encountering more and more friction and it's slowing down more and more, so you're able to see it for a bit longer. Any guesses on what they call something that's even more bigger than a few inches across? They should. They have a special word for it. It's actually two words. They didn't think too hard on this one, though. They call it a super bolide. So you can write this down, too. And, of course, the most recent super bolide exploded over Russia. That's just what space objects do. This was, I want to say, 6 years ago, maybe. I'll bring up the YouTube clip if we got time at the end. We should have plenty of time to see that. And this is that one that occurred in Russia. As you can see, there's snow on either side. And these, well, you'll see in the video how strong they can be and what effect they have. So when is the best time to see meteors? So the thing is, meteors and them impacting Earth, usually they're just little things that are along the orbit of the Earth. As the Earth goes around the sun, if you looked at the places that the Earth is going to pass through, you're going to find little bits of rock and dust. And those things that we run into turn into meteors because they streak through our atmosphere like we've mentioned. So I'd say from this slide, write down the title and write everything up through there. You can skip the bottom one. That's something that I'm just going to help you visualize this with. Yep, sure. Here we go. Just fill this out the rest of the way for me there. Thanks. It's September 4th. Looks like it's about 12:53. No. Thanks. Here we go. A vast majority of meteors burn up in the atmosphere and there's nothing left. They just vaporize because they're moving so fast. Why is there always more? Just because as Earth goes through its orbit, we've got so much gravity that even if we don't hit some of those little bits of rock the first time around, the gravity that we have might pull them into where we're going to be in a year. And so we just continually do that and run through them. So the question is, though, why is it that most shooting stars actually occur at dawn? If you look for a shooting star, especially at sunset, that's not going to go all that well for you. You're hardly going to see anything at all. And so the question is, why does that occur? So I have the Earth here. Got the whole world in my hands. And this is a special world. It was the world as it existed in 1992 when I got this globe as a little boy. So we still got the USSR here. So we'll say that the camera represents the sun. And now this is like sunlight, right? And here's the United States. So what time is it right now? Noon. Sun's right overhead. Now, if the sun is just barely coming up over the west coast, is that sunrise or sunset? That's sunset, because the sun sets in the west. So at sunrise, we have our east coast right here. So this would be representative of when the sun is just coming up in the east. Now the Earth moves in its orbit in this direction. So if the Earth is moving in this direction right now, you can see why we're going to be getting a lot more meteors under those conditions. Because when you look up at sunrise, you're looking in the exact direction that the Earth is moving in its orbit. So if there's any meteors out here, I should say meteoroids out here, then the Earth is going to run through them straight away like this. Now, if you're on the other side of the Earth in the USSR, you're not going to see any of that. It's midnight, so it's nice and dark out. Or no, it's not midnight. It's dusk over here. It's sunset there. And you can't see anything because you're on the opposite side of the Earth that the Earth is moving through. We're moving through this way. It's going to be awfully hard to see meteors from the other side of the Earth. And at midnight, that would be on the other side of the Earth. You might be able to see a few on the horizon, but it's always best to check for meteors and fireballs and things during the sunrise. Unfortunately for us, if you're more of a late person. So, questions on that cute little analogy? Okay. You can write this one down too. Maybe you've seen enough meteors in your life, and you're like, forget that. I just want to see fireballs. Best time to see fireballs is around March 20th when spring starts. There you go. Whole thing. What's it? Yeah. So just as a quick refresher, we've got meteors, fireballs, bolides, and super bolides. Can you put those in order of least bright to most bright for me? What's the first one? Yep. Nope. Fireballs are next. So meteors, then fireballs, then bolides, and super bolides. Yep. So that's going from dimmest to brightest. It's kind of, you should know that order. Meteors are the dimmest, then fireballs, bolides, and then super bolides are the brightest. So the question is then, why is that we can see fireballs so much better and more often when spring starts? And all I can tell you is that when the Earth goes around the sun, the objects that we run into that turn into fireballs and meteors and things like that are already located at those positions. So when spring comes along down here, all this means is that when the Earth is passing through some of that material, it's just a larger chance that we've got bigger pieces of dust and rock in this area. No one really knows exactly why that happened, if a comet passed by and maybe left some of its material there. But there is just some larger material here as opposed to the rest of our orbit around the sun.
So how big?
To get to be a fireball, it needs to be a few inches across or a little bit bigger.
So the shooting stars we see, like what's the diameter?
It could be from this size to maybe this size for your standard shooting star. A little bit bigger than this, if you're looking at home. A little bit bigger than this, you're going to get a fireball.
I always thought they were like.
No, they're actually a lot smaller, yeah. Meteorites. You want to make sure that you know this. So you're going to have to write down meteorites and the first bullet point. You can skip the bottom bullet point. That's just some trivia. I know, right? Right. Mm-hmm. Yeah, I'm not sure who came up with that. Maybe they just wanted a standardized way to name these things. Maybe it was what?
Maybe it was a post office.
Could be. Maybe it was the Soviets. So yeah, meteorites are the last stage in this whole process. It starts as a meteoroid, then it streaks through the sky as a meteor, and then if it actually does make it to the Earth's surface, and you can pick it up and look at it, that's what a meteorite is. So make sure you know the differences between all those three things. And the actual meteorite is named after the post office that's closest to it, for some reason. I don't know. Maybe the post office found the first meteorite, and they're like, from this day forward, post offices will also have this important duty. No, this one was just, that's a crater. There might be a meteorite at the bottom of it. Yeah. Wait till you see one of them coming up soon here. There's different types of meteorites. Write down types of meteorites and then just stone and iron. You just need to know the two different kinds. Any idea why the iron ones that we find would be bigger than the stone ones that we find? Yeah, exactly. So we've got stone meteorites, and because they're stone, they're kind of brittle. But if you take a big block of iron, it's going to be a lot less likely to break apart in the atmosphere. And so these keep their shape and their size longer. Peak scale meteorite, this is a fun one. This was, I think, the most recent one that was actually covered well. So write down peak scale meteorite. Then go ahead and write down the third bullet point. And then the dash mark. So it hit a car, and when they found it, it was about the weight of a bowling ball. That poor Malibu. Makes you wonder if that sort of thing would be covered by insurance.
We're like, yeah, we don't have a meteorite.
They had to make a new box for that.
Yeah, nobody.
Right. Yeah, yeah. This hit the ground in Russia with their luck. It would land on a nuclear facility.
It causes another Chernobyl.
Right. Or worse yet, it slams into Chernobyl. So yeah, it damaged that Chevy Malibu. It was actually green as it was traveling through the sky. The next picture you'll see what it looked like as observers saw it. You can probably guess, because it was recovered as being the size of a bowling ball, that it started out quite a bit bigger than that. And you can see by the picture that it broke up on its way through the atmosphere. There it is right there. So it was just the leading edge of it that was found. Who knows how big it was when it began its journey.
So is this considered a fireball?
This would be a fireball, yeah. To be a bolide, it would have to actually like explode in the air. And there's the Malibu. And there's the meteorite. Yep, right through the back bumper. That taillight never had a chance.
Why did not put a hole in the ground?
Well, I feel like
Well, this didn't like go through the
Maybe they might have moved the car. I don't know.
Like, why is your car so slow? Oh, meteorite hit.
All right, as far as this goes, this is the largest meteor crater in the United States. Right down just the very bottom part here. So, of course, they named the city Meteor on account of the thing. So, of course, the post office right next to it is Meteor Post Office, which is why it's meteorite. So just know the crater is about 4,000 feet across. Make sure you know that number. 570 feet deep. I think those are the only two numbers that you should know for when you have the quiz. Yeah. When it's traveling that fast, as we'll see, we've got a lab later on where we deal with craters and how fast things need to be moving to make the craters big. You'll see exactly what this is all about. If you look real close, you'll see there's something kind of at the bottom of this. It's actually a little research laboratory. This is what it looks like a little bit further back. And it's actually a pretty popular tourist destination. I've never been there myself, but I'd want to go there sometime. Probably not the safest place to bring your stroller, but I know. You know what I think would be awesome? To bring like a hang glider and just jump off the edge. Just glide all over. Or land on the stroller, right? Alright, meteor showers. We got to talk about these. So meteor showers occur because as comets get close to the sun and they lose some of their material, like we talked about last time, that material remains in the orbit around Earth if that's the area that it passed through. You can just write down meteor showers. You don't need to write down anything else from this slide for now. But in terms of these meteor showers, when the Earth passes through that material that's left behind by the comet, you have certain areas where we can expect there to be more meteors during a particular night or week than usual. And you might have heard of some of these before, but first here's just a little visual description of what might occur. So if the comet's orbiting like this, and it's getting close to the sun, so it's losing a lot of its material. If it loses its material in the path that the Earth takes around the sun, then when the Earth gets to this spot, we're going to see all sorts of meteors there because of all that junk that's in the sky, that's in space in that position. So for this slide, write down most active meteor shower, write down Perseids. Also, write down the last two dashes. So Perseids is the most consistently active meteor shower out there, and it peaks around August 12th every year. Where it says more than one meteor every minute, this is under absolutely ideal viewing conditions. You'd have to be way out in the middle of nowhere with no lights in order to see that many meteors in an hour. And it has to be a very active season for that. But consistently, Perseids will give you the best light show.
You have to be like somewhere on Earth. There's a certain spot on
Nope, everywhere. Of course, the best time to see it is at dawn, but anywhere on Earth is the best place to see those things. And this is time-lapse picture. Maybe this is a minute or something. And they're all going to seem to come from Perseus, which is a constellation. And they'll tell you on the news when it comes around that where you should look, whether it's north, south, east, or west. So there's Perseus right here. All the meteors are going to kind of originate from that area. However, the most spectacular meteor shower is the Leonids. So write down the title, Most Spectacular Meteor Shower, and Leonids. So those three things that I have arrows next to, write all that down. So the Leonids is one that you kind of want to be aware of because every so often, it's consistently not as good as Perseids, but I'm getting ahead of myself. Every so often it has an awesome meteor storm. And these are where you've got tons and tons of meteors every hour. The last time these storms peaked were in 1999, 2001, and 2002. So if they come every 33 years or so, it might be another decade before that happens again. But when that time comes around, keep your eyes and ears open and maybe we'll see something spectacular. You can see in a couple slides here how spectacular this came. It was actually so spectacular that it ended up killing a lot of people one year. So there's your time-lapse picture.
Yeah.
And this is an artistic representation of what it looks like, or what it looked like whenever this was drawn. So can you just imagine looking up and seeing just a shower of meteors coming down from the sky? How awesome that would be. We'll get to it. It'll be something that you put in your notes. So this is on your handout. If you want a little cheat sheet on when to look for the next big meteor showers, these are the main 5. So the next one coming up for us would be October 21st, the Orionids meteor shower. You'd have to look towards Orion. By the end of class, you'll know what that looks like and where to find it. So yeah, about killing people. Can meteor strikes hit Earth? Yes, they have. In the 1400s, that happened in China. You're going to want to write this entire slide down. No, like they didn't have cameras and stuff in the 1400s, so I just tried to find an old picture of something with a big meteor shower. So this isn't what China looked like back then. But this is an artistic representation that they drew of the Leonids meteor shower whenever this was made, so it gives you an idea of how spectacular this can look in the sky. As long as the stones aren't falling like rain. And I'm kind of surprised that it only killed 10,000 people. I mean, even in the 1400s, there were a ton of people in China. And another picture there that was drawn. I really hope that the next time around Leonids turns into a big meteor storm. It would be a really cool sight to see something like this. And I actually have this up on the side of the classroom there. When you wish upon a falling star, your dreams can come true. Unless it's really a meteorite hurtling to the earth, which will destroy all life, then you're hosed pretty much no matter what you ask for. Unless it's death by meteor. And this is what meteors look like from space. That's the little streak from the meteor going through the atmosphere. And one more little piece of eye candy for you. The end.
So, when you notice the little tail, is it just gone then?
Yeah, it's disintegrated into the atmosphere. And
So if something like comes all the way to Earth, you'd see the streak the whole time?
yeah, you would.
Okay.
Yep. So it's very rare. Very rare.
Last year or something?